Hello, everyone, and welcome to the first DevSecCon Ottawa, or DevSecCon Canada. Hope you're all well and you're traveling well into January. Well, January's almost over. Where did that time go? I hope everyone had a great holiday break. It's not too late to say that, and that you got all those amazing holiday projects done. I know I always have like projects that I want to do over those holiday breaks. I never quite get through them all, but I always get through a couple. So I hope you got through those projects that you were aiming to get through. So for those that are new to DevSecCon and are joining us for the first time, DevSecCon is a chapter of the global DevSecCon community, which is an inclusive community that enables developers, security practitioners, and, well, any tech enthusiasts into the wonderful world of security, applications, and building out DevOps, all things DevOps, pipelines, you name it, CI/CD, so many things. And just like you, we're all here to, well, learn, share what we know, and, well, the way I like to think of it is you're just here to geek out, which is one of my favorite things, and one of the things I love about communities like this. So, and coming up today, we'll be joined by Magno Logan, who's an information security specialist at Trend Micro, and is also the chapter lead for, well, this very DevSecCon. So I'm just helping out today. I'm actually the DevSecCon chapter lead for Australia, for Sydney. So I'm fortunate enough to be dropping in today to, well, not only open it up, but also intro Mango, who will be talking about one of my favorite topics today, which is software composition, Business 101, knowing what's inside your apps. And coming from a background as a developer, many years as a developer, this is really important and something, well, something near and dear to my heart. So, but before we dive into the talk, I just wanted to quickly introduce myself. Hello, my name is Developer Steve. So I'm one of the senior developer advocates at Sneak. And, well, I've been developing apps for so many years now, and security in particular, and building security into DevOps infrastructure is super important. And today's topic, I think, is going to be, well, I don't even think, I just know it's going to be absolutely amazing. So, and Mango's, just some background on Mango, I know he'll probably introduce himself a little bit, but Mango is a seasoned security professional with a wealth of experience, and today we'll literally be talking about one of my favorite things. So, before we do get into that, just a few more things. We do love feedback. I've already put the link into the chat for our Discord, so please join us on there and drop any questions into the DevSecCon Canada channel, which we've already got set up. You can also request talk in there, and all our speakers from DevSecCon are in the Discord, in the Devs. So please join in there and reach out. Let people know what you think of their talks. Ask any questions. We just geek out, which is, again, one of the things I love about these sort of events. It's totally the best place to interact with speakers in the community. And yeah, check out the DevSecCon, which is specific for this live stream. If you're check out the live recording, hello from the past, you can still ask in the Discord. We're all in there, and there's a growing of enthusiasts just like you. So, DevSecCon is brought to you by Sneak, and our aim is to create vendor-neutral knowledge and practices related to software security, and, well, like I keep saying, just to geek out and just to connect. Well, that's enough for me. And so, without further ado, I'm going to bring in Mango to do his presentation. So, let me do some switching. Hello, Mango.
Hello, Steve. Thank you.
How are you going?
Good.
Awesome. Let's bring we'll go into screen mode.
Mm-hmm.
There we go. Awesome. Over to you.
Okay, thank you. Yeah, hello everyone, and welcome to this first meeting of the year and first meeting of this DevSecCon Canada or Ottawa chapter, however you may want to call it. As Steve mentioned, right, my name is Magno. I'm gonna be presenting for you today. I'm the chapter leader of this DevSecCon chapter here in Canada, but the idea is for me to usually bring different speakers to talk about different topics related to application security here for everyone. I'll just this time I'll be opening with my presentation, and I hope you enjoy. And yeah, let's get started. Feel free to ask any questions, and either on Discord or wherever you're watching this from. And if you're watching the recorded version later, if you want to reach out to me, I'll also provide you with some my contact information and everything for you to talk to me about this topic later. Okay, so let's start. Yeah, just a little bit about myself, right? As I've been in the field for over 10 years now. I'm an information security specialist at Trend Micro, doing a lot of cloud and container security research recently. But my background is on development, right? I used to be a Java developer before joined to application security and before doing some research work as well. I've done a lot of pen testing and web application security testing on different organizations. I manage web application firewalls and have done some source code reviews of different code and different languages as well. So I've been working with that kind of area for a while now, and also worked with many different tools regarding mostly SAS, DAST, and SCA, right? So static analysis, dynamic analysis, and software composition analysis, if you don't know the meanings. And I think since 2017, 2018, SCA has gained a lot of attention, and I was pretty much interested in deploying and helping developers secure their code and secure their dependencies as well. So we're going to talk more about SCA today here. So it's going to be a very introduction overview of SCA, how different tools work, and what you should look for when looking for protecting your libraries and your dependencies in your code. And yeah, more related to dependency checking and software composition analysis. Besides that, as I mentioned, like I have a few social media networks that I use here, mostly LinkedIn and Twitter. So they're both Magno Logan. You can easily find me there. But I do have a personal blog, catenasec.com, where usually I try to write some articles there. But besides the articles, there's all my contact information if you need to reach out to me, and all previous kind of presentations and talks. It's a bit outdated, I know, but there is a lot of different talks out there since I started presenting in 2010, 2011 maybe. So some of them are just slides, others are videos that were recorded, and so it's all available for free there for you to take a look. Okay. So the agenda for today, right? The agenda for this talk is the goal was mostly to introduce the DevSecOn Canada chapter, right? I discussed that with Sam and the guys at Sneak last year, and we said no, let's start in January because beginning of the year, right? Everyone is excited to get things done and join different communities and hear different things. So we decided to start this chapter here in 2022. And yeah, the agenda is just an overview for, as I mentioned, for software composition analysis. We're going to talk about what is SCA, what is a BOM or bill of materials, and what is a software bill of materials, right? What does that mean? Why you should worry about it, even if you're not in security, right? If you're a developer or if you're a DevOps engineer, why should you worry about these things? The dependencies and libraries isn't that like more a security problem? And we're going to understand that in the next few slides. And then we're going to cover a little bit about supply chain attacks, right? So there is a lot of discussion lately since last year about supply chain and how those attacks can be performed via those dependencies and libraries if they get compromised, right? If you're using a vulnerable version or a malicious version of that package. So we're going to understand that as well and why that is important here for us. Then talking a little bit about some software composition analysis best practices, and I'm going to mention that throughout the presentation, not just a best practice for when you're using the tool, right? When you're using a solution or a product out there or open source version of a software composition analysis tool, but also when you're looking for one, when if you're doing some trials and POCs, like what should you pay attention to? Okay. And at the end, just mention some SCA tools. And if we have time, I'll probably do a demo of Sneak, which is the tool that I chose to do the demo today. It can be any others, but I'm going to show how easily and quickly you can get yourself up and running with SCA and with Sneak as well. Okay. So yeah, SCA, you may hear different names out there. People call library analysis, third-party dependencies, or open source security. So there are different names, but they're basically meaning the same thing. The goal, the idea is, okay, what about all those packages and dependencies that I have in my code, and I don't have any solution or any tool to look at that, right? I'm usually not doing a static analysis on all that code, and even if I am, how am I going to fix that? Because that code doesn't belong to me. It's not a custom code made by my developers, right? So how can I prevent my application from being vulnerable or being using outdated libraries if I don't have access to that, or I can't change the code itself, especially in some situations, in some libraries that can be closed source or commercial libraries as well, right? So it's even harder for you to try to submit a pull request and reach out to the developer to fix that bug. So it can be tricky sometimes. The idea with SCA, right, and software composition analysis is I need to understand what I have in my application, right? What is my application made of? It's basically nowadays we don't develop code from scratch, right? We use a lot of frameworks and libraries and other resources that are available to us so that we don't reinvent the wheel. Right? There is no need for that. There is usually a need to build software faster because of the time to market and the business purposes and other different kind of reasons. But the idea is that usually today we leverage a lot of other people's code. And when I say other people, it's not just people from our organization, but open source software, and these developers can be anywhere from other countries, other places out there, and you don't know, right? So how you can ensure that the code that you're using, and since you're using that in your application, you're trusting that code, how can you ensure that that's safe, right? That's reasonably secure, that's up to date, or doesn't have any public known vulnerabilities, right? So that's basically the goal and the idea of software composition analysis. There are some other features as well, like verifying licenses, right, or license verification to make sure that if you're using an open source software, you're not breaking that license. If you need to share your code of your application as well as open source, you are aware of that and you agree with that as well. Different things that we're going to talk about today. And there is something that the SCA solution or tool provides to us that's very important, especially now with discussions around open source and the latest issues with the Log4j vulnerability last year, right? Which is the software bill of materials. And we're going to understand what that is in the next few slides, okay? Okay, so to build basically a tool or a solution to do SCA scanning, software composition analysis, and everything, I need at least three things, right? I need an application manifest, right? Giving me instructions on how the software should work and what are the, how can I build it and what are kind of, how do I set it up and everything. But I also need another information which might be together with the application manifest and sometimes can be a separate file, which we call the dependency metadata. Right? The dependency metadata, it's basically a file which has a list of all dependencies in my code. For example, if you have a Java application and you're using Maven to build that application, it's probably going to be inside that pom.xml file. If you're using a Node.js application, it's going to be on the package.json, and different languages have different names or different files for hosting that dependency metadata. Okay, that's fine. I can do that. But to understand and to check, right, to correlate if my library is vulnerable or is outdated or has any kind of licensing issues, I need some kind of data source, right? And the data source that we usually use is called the vulnerability data source, which can be, it's basically a database of vulnerability information about those libraries, right? And this data source can be like a public data source, such as the National Vulnerability Database, or NVD, which is the most common one, which is public. And it can be a private one. Some organizations, they build their own data source because besides information and NVD, they're able to collect other information to enrich their data source, which makes it better and easier to detect and have less kind of false positives, and also detect information and vulnerabilities faster, right? So it depends. But most of the open source tools, they usually lever the NVD, or a public data source of vulnerability. So I have a list of my libraries and their versions, and then I go check, is there any vulnerability for that specific library in that specific version? Oh yes, there is. Okay, what do I need to do? Do I need to update it? Is there a fixed version or not? And so on, right? So that I need something to correlate what I have in my code, or what I have in my application, and what information is available out there regarding those libraries. Okay, so what is a bill of materials, right? I mentioned the software bill of materials, or the SBOM. That's a term that you're probably going to hear a lot more this year, and especially with the issues and some of the topics that we're going to mention later in this talk. But the software bill of materials concept comes from the real world, and the real world means the bill of materials, right? So the bill of materials, it's basically a kind of a document, or there is an example here on the slides, a representation of the list of components or ingredients that I use to make like a product, right? For example, here we can see that there is a list of materials for probably building a house, right? And it shows the manufacturer, or the model, and the suppliers, and the unit prices, and then I have the total, right? So to build this house and to have all the necessary kind of materials for my house, I'm going to spend this, and I'm going to need all these products from all those suppliers. Okay, basically that's that, and we're gonna have some different analogies as we go here. So a software bill of materials, it's basically the same thing, but for a software, right? For application, okay, to build this application, what do I need, right? What kind of packages and libraries do I need to import and to download from, and which version specifically do I need to have my application up and running, right? So it's basically the list of components in this piece of software, the software bill of materials, or SBOM for short, right? And basically, it's very similar to ingredients in a packaged food, right? So there's different analogies out there. It can be sometimes people compare to kind of the nutritional information about the product or kind of the components out there. And it's usually made of open source. Most of the kind of libraries and dependencies that we have are open source, but it can have some enterprise or commercial libraries as well, and even custom libraries that you made on your own organization, right? So this is an SBOM. This is a software bill of materials, and that was kind of a big deal, as I mentioned in the recent events with the Log4j or Log4Shell vulnerability, because what happened was people didn't know if they had this library in their code or not. Right? They knew that they're using some Java application, but they didn't have a software bill of materials. And sometimes even if they had it, it wasn't up to date, or it didn't have information on indirect or transient dependencies, which is something that we're going to talk in a bit. So they didn't know if they were vulnerable. And I think it was Sneak that published this research where most I think 60 or 70% of the Java applications that were using Log4j, they were using that indirectly, in a transient dependencies. And what that means is I'm calling a library or a dependency, and that library is calling Log4j. So in my code directly, I don't see any calls for Log4j, but that library calls Log4j for me, right? So I'm still vulnerable, right? But I don't have that information. I can't see right away, especially if I'm not using an SCA or if I don't have an updated SBOM for my software, right? So that was kind of what created the whole turmoil or the whole kind of issue with the Log4j vulnerability, right? Okay, but how can I start creating my SBOM, right? My software bill of materials. And there are some kind of standards out there. There are some resources available for you, right? It's the ones that I'll mention here are just some examples. It's not a definitive list, but you can definitely look it up and try different ones out there. So for generating your SBOMs, the first one that I like to mention here is the Cyclone DX, which is basically a lightweight SBOM standard from OWASP now. Belongs since last year. It joined OWASP as a flagship project. So Cyclone DX is a famous one. And another one is SPDX, which is basically a different standard now from the Linux Foundation, right? It's an open standard for sharing and communicating your SBOMs and your list of dependencies on your software. So there's different options out there. And another one, which is not the standard, but it's a solution or an open source project from OWASP as well, that allows you to kind of identify and monitor your SBOMs, which is Dependency Check, right? Dependency Check is one project, and we're going to see another one later, which is Dependency Check. So not to confuse both, they complement each other. But the idea here with Dependency Check, it's just understanding, okay, what are my libraries in this application? Are they up to date, or where they come from, right? Do I have any issues with those libraries? And it's not checking specifically for vulnerabilities, but helping you generate your software bill of materials, okay? Okay. So why should I worry, right? Okay, I talk about this and then SCA and SBOM, and especially if you're like a developer, it's like, okay, that's not my problem. That's a security problem. They should worry about it. And no, right? That's in your code. That's it. It's in your applications. And I know that developers are usually kind of afraid of updating things and updating libraries and changing code that might break the application. So we need to understand why that's important, right? So Synopsys did a research in 2020, and basically what they realize analyzing open source projects is that 84% of those code bases had at least one vulnerability, right? With an average of 158 vulnerabilities per code base. So that's a lot of issues and problems in your dependencies alone. Another thing here on the right side of this slide is that, okay, before in 2016, right, our projects and applications usually had an average of 84 open source components per application, right? So that means 84 libraries or third party or dependencies that you had to make your application working. And with the latest number from 2020, which is basically 2 years ago, right, the average of those components jumped from 84 to 528, right? So this is counting the direct dependencies and indirect ones, right? So we have 528 libraries in one application that I need to be aware of and make sure that they're up to date and they don't have any kind of vulnerability, right? So the problem is becoming even harder to manage nowadays. Another information here on why should you worry, right? Basically, this report from the State of Open Source Security from SNCC from 2019, which is the latest one that I had, shows here the number of libraries and packages and dependencies being created every year on different package managers, right? Which means different programming languages. So here we can clearly see that there is an increase of new packages, and especially on Node and JavaScript code, right, which is the NPM package manager there. There is a lot of libraries and a lot of frameworks being created for JavaScript, right? And that creates an issue. We see at least once a week or once a month some packages from NPM being compromised and like mining cryptocurrencies or stealing credentials from other kind of their dependencies or whoever is using that dependency. So there is usually some news around that, and that's something that you should worry as well as a developer or as a DevOps engineer, right? Okay, so let's understand how big is the problem or how deep is our issue here. And this is a slide that comes from Mark Curphey, which is one of the founders of OWASP, and he also had this company called SourceClear, which developed software composition analysis, which later got sold to Veracode. And there is a lot of other research around this topic where we see how much of our software, our application is made of custom code from our developers that work in our organization, and how much of our software is made of libraries and third-party dependencies and all that stuff, right? And so the research says that's 10 to 30% of our code, of our application, is our own code, right? It's code developed by our own developers. And 70 to 90% is open source code. It's third party, it's libraries, frameworks, and other things, right? So all that stuff that's being used to create our application and that we're trusting in that code, it's not being verified, right? We're not checking for any issues. Right? We're not checking for vulnerabilities and stuff like that. So how can we improve that, right? So this is basically, usually I ask myself, right? So if I want to cover the kind of protect my software and I need to choose between protecting the custom code or protecting the open source code here, at least from my perspective, if I want to cover a broader attack surface, right, I should probably focus on the open source code, right? I should probably focus on protecting my libraries and dependencies first before I can start focusing on the custom code, right? So that kind of makes sense to me here. Okay, but it's not as simple as that, right? There are many kind of issues with updating those libraries, and there is the problem of direct and indirect dependencies. And I highlight the issue here with an example that we did with a research that we did with Docker and Kubernetes as well. So those images can have different libraries, and those libraries depend on other libraries, and that can be very tricky to manage as well. So indirect dependencies is even it's a problem that kind of complicates a little bit more for us to fix that issue, right? Because if my project is using library X, right, and that library is calling library Y, right? And let's say there is a vulnerability in library Y, but not in library X, right? And I'm going to show that in the demo, but let's try just to think about it here. Okay, so how do I fix the problem with library Y if there is no updated version for library X? I'm not calling library Y directly, I'm calling library X, right? So I would have to go to reach out to the developer of library X and ask him to kind of generate or build a new version of his library with the new updated version of library Y. Otherwise, I'll have to do that manually, right? I'll have to download the code and do the patching myself, which can be very tricky as well. Another issue is that, especially when you haven't done SCA and you haven't updated your libraries in a while, usually the problems and the versions of the libraries that you need to update to, they're going to be kind of major versions, and then that can break your code, right? So it's important here to have proper testing, especially regression testing, to make sure that once you update a library, your application is still working. Otherwise, right, it's going to break the code, and we're going to see that in the demo in a second. Okay, so this was the OWASP Top 10 2017, and I'm going to show the latest version as well. But we can see here that even on the 2017 version, it already talked about using components with known vulnerabilities, right? Which was the A9 position here. But that jumped to the 6th position on the OWASP Top 10 2021. Right? It was released last year, and they changed the name a little bit to vulnerable and outdated components. But that's becoming even a bigger problem. And if you're not aware of the OWASP Top 10, right, it's basically a document that kind of lists the top 10 most kind of web application security risks, right? And should definitely take a look if you haven't seen it before. The 2021 version is the latest one. And yeah, this is a problem. It's not just me that's saying that. It's OWASP, which is a big community of security professionals out there, right? This is a problem, and it's increasing even more, and we need to take care of that. Okay, but how does this library affects my supply chain or my pipeline, right? So imagine, as I mentioned with the NPM example, imagine that an attacker is able to compromise that source code of that library that you're using, and it's able to inject malicious code to collect your credentials or to mine cryptocurrencies, right? With that, if you download that latest version, which was injected from that attacker, then your application in your organization is at risk as well, right? So the problem here with the supply chain is that we need to make sure that the code and the libraries that I'm using in my code stays the same and it's reliable, right? It's verified. It comes from a trusted source. That's a word that we usually use when talking about supply chain. It's called provenance, right? Provenance. I know where it's coming from, that library, and I can verify the signature, and I know that this version wasn't tampered with, and all that stuff, right? So it's important to protect your libraries as much as you want to protect your application, because you want to prevent any kind of software supply chain from happening, right? We had the issue with the SolarWinds earlier last year, and also the Log4j, we could generate a supply chain issue as well. Okay. In the topic of supply chain, the Cloud Native Computing Foundation, which is a kind of another group that I'm part of, they produced a white paper last year called the Software Supply Chain white paper. It basically covers everything that you want to, kind of best practices that you want to protect from your pipeline, from the source code, from the build pipelines and artifacts and everything, and how you should implement some security controls there to verify that exactly the code that's being produced, that's being generated by your developers and committed to your repos, is the code that's running on your applications in production, right? Nobody tampered with that code during your pipeline or during your supply chain, okay? So that's a kind of a interesting reference material that I highly recommend you take a look. And the links are there, and probably we'll share the slides later after this talk, and we'll add the link on the description on the videos, okay? On the topic of supply chain yet, right, we still have, if you don't believe me on how much supply chain affects your software and your applications, we have a lot of examples here. We have a list of a catalog of supply chain compromises, right? So every time there is a compromise, issue, or a vulnerability or an attack that affects some part of the supply chain of the software, we list it here in this repo, right? And we make sure that we specify what type of the compromise it was, if it was something affecting the infrastructure or a developer tool or the developer itself, right? There has been attackers that targeted the developer itself, the developer machine, to compromise an organization, right? So this here is just some examples for you to look at and see what happened, understand how the attacker took place, and understand how you can prevent that from happening on your organization as well. Another interesting thing, and this covers basically new approaches to software development, which is using kind of the browser IDEs or cloud IDEs, right? So this is a research that we did in our team at Trend Micro, the supply chain attacks in the age of cloud computing, which was done by a teammate of mine from my team there. And it basically analyzes the security of those web IDEs or online cloud IDEs, right? So you have like the AWS Cloud9, you have the GitHub Workspaces now, and you have like a Visual Studio Code Online for Azure or something. So he analyzed that as well and showed there's also some security risks that can compromise those IDEs out there. Okay, so that's something to be aware of too. And just to kind of finalize the topic of supply chain here, right? We still, I know we're DevSecOn Canada, and we're talking from Canada here, but we need to understand that this US executive order affects us and affect different organizations that provide software to the US and US government organizations, right? So this was published last year, May last year, and there is a whole bunch of stuff in this document, but there was one specific thing that focused on the software supply chain and how the US government is going to kind of demand, right, and check and enforce that any company, any organization that provides software to the US government, they have this accurate and up-to-date data of the components and third-party software, which is basically talking about having an SBOM, right? Having a software bill of materials. If you're selling me your software, you need to tell me what your software is made of, right? What are the ingredients in your software, right? So I need to understand if that's a risk for me or not, if I really should buy your application or not, right? So that's another important thing that talks about the subject of SCA and also supply chain, as well as the topic mentions here on the executive order, okay? Just to kind of finalize before we go into the demo, I'm just gonna give some comments about different tools out there, SCA tools, and of course we're gonna cover Sneak here as well, but there are different out there, right? If you want to try it out, if you just want something that's open source, I would like to I would maybe recommend checking out Dependency Check, which is an OWASP project, has been out there for a while now, and it supports different languages, mainly Java and .NET, but other languages as well. And it's open source. You can start using right away, and you have plugins for different kind of CI/CD tools as well. So it's a good one to try it out, especially if you're using those languages that I mentioned, right? Another solution that's out there, and I think the dependency check also leverages that, is the retire.js, which is basically a script or a tool to check for outdated JavaScript libraries, right? So let's say you're using an old version of jQuery or something like that, and then it's going to let you know about that. So you can check your JavaScript libraries, your front-end libraries as well. And there is even kind of a plugin, right, that you can add to your browser to when you access a website. Retire.js is going to check that for you, and it's going to show if that site that you're accessing, if that site is using any kind of outdated library or not, right? So that's pretty neat. And there is the Sneak free for open source, right? The Sneak.io, which I'm gonna show here in the demo and show like how we leverage that. It's kind of one of my tools of choice, especially when it comes to SCA. It's very handy, very easy to use, and it's free for open source. So if you have projects, open source projects, if you have any kind of public repos, right, you can use that right away and start using Sneak, and I'm going to demonstrate that here today. There's the open source security by Trend Micro, which is powered by Sneak as well. So it's a good solution if you're already using the Trend Micro products and the Cloud One kind of platform that's easy to set up and install on your projects as well. And there are other kind of commercial and more enterprise solutions out there, such as Veracode and Black Duck. Okay. Yeah, I believe that concludes. Yeah, that concludes the kind of the presentation part. I'm happy to take any questions if you have them. Otherwise, I'll just kind of switch my screen here and jump into the demo. Sounds good? How we're doing there, Steve? Let's see. Good.
Yeah, really good, amazing. I also have some questions, but if anyone watching live has any questions, I'm keeping an eye on the Discord and also the comments. So please drop them into respective chats, and we can ask those after the demo. But yeah, going really good so far. Really keen to see the demo, and fingers crossed that it works.
Okay, sounds good. Yeah. I shared my screen already, so you can put that on the screen. Yeah, awesome, great. Okay, so let me go here. 1 second. Okay, so let me just log out here. So we can log in again. And this is sneak.io, right? Very easy to find and very easy to type, very short name. So that's good. Basically, if you don't have an account, you need to sign up, right? Which is free, and you can connect that to your GitHub repositories, and Sneak is able to detect that and list all your repos on the Sneak platform, and you can choose which ones you want to start scanning. So I'm going to log in here into Sneak and already have an account there, as you saw, and I'm going to use GitHub, right, to authenticate to Sneak, which basically gives Sneak permissions to read all my public repos there and start scanning the ones that I choose, right? I have some other repos here already, but we're going to do one from scratch. And the one that I'm going to do, it's basically the one that I usually use for my kind of trainings and demos. That was kind of, what's provided by Sneak is a fork here of the Node.js goof, which is basically like a to-do list application done in Node.js in JavaScript, right? So this is the project that I'm going to use. As I mentioned, as I'm logged into Sneak already, it's already able to see my projects from GitHub, and we're going to see how we can do that on the platform itself. Yeah, I can cover some of the interface later, but let's start adding a project here. So there is this kind of button here, add project, and I can choose different projects to add. Nowadays, the Sneak platform is not just an SCA tool anymore. It has different modules and different features, so it can analyze Docker files and Kubernetes YAML files as well. It can do some static analysis too. So if you want to do that with Sneak, you can do everything. So once I add a project here, the platform starts checking to see if it can do all those analyses and reports all those kind of issues or vulnerabilities here for me, right? So I can do either scan an image from Docker Hub, I can do the Sneak CLI. So if I want to, especially if I want to automate some things to the pipeline, I can do that as well. And there's even GitHub Actions, right? If you're using GitHub Actions, that you can leverage to run your scans using Sneak. Okay, so for GitHub here, that's the one that I'm going to choose. It's basically going to list all my projects there, and I'm going to choose one that I want, which is the goof one. I have other projects there. So yeah, there's two here. That's the one that I want. And basically, right, it's just listing my projects from GitHub and choosing the one that I want to analyze, right? There are some other options here on the settings below, which basically means, right, I can exclude some folders if I don't want Sneak to scan those. If there's like testing folders and other stuff that I don't want it to report and be like false positives, right? So I can remove those here. And there is also an option here to specify like a specific location or a custom location for my dependency metadata, right? The file that has all my libraries, if it's not on the standard format or if I'm using kind of a different language that Sneak is not able to identify, I can list that here. Basically, with the software composition analysis part, that's what we're going to look here today. The Sneak is looking at basically these two files, right? The package.json, the package.lock.json. And here we can see the list of libraries and versions of the libraries, the direct libraries, right? Not the indirect ones that I'm using in this code, right? So we have different libraries and versions here, and we're going to, basically, they're going to scan that, check their version, and see if they have any vulnerability information for that library in that specific version, right? Okay, so once I do that, I don't need to change anything below here. Basically, I just need to add the selected repo, and Sneak is going to right away add a new project to my list of projects here, and it's going to start scanning. Right? So it takes a couple seconds, maybe a minute sometimes, but it's fairly straightforward and very quick. And even if I change anything in the code later, Sneak detects that, and it's able to run a new scan again. And we can do that in a second as well once we update. Okay, so it seems that imported here. I'm just refresh to make sure that's here. Okay, here. Yeah, this is my project, Magno Logan /goof. And there's two kind of three results here, right? As I mentioned, the code analysis, which is a static analysis or SAST. There's the Docker file analysis, which basically analyze any kind of Docker files in my code that I have there. Some of them are test code, but it's fine. The one that we're worried about and that we're going to focus on today is the package.json, right? Since this is a JavaScript node application, I'm focusing on the dependency metadata of the JavaScript, which is located in the package.json. I can quickly see here the results, right? The overall results of vulnerabilities and the one by kind of different scans or different features. You can see that critical, highs, mediums, and lows, right? So we have different categories or different severities of vulnerabilities, which is nice, right? And so let's take a look at this the package.json. Right? So I just need to click here. And basically, what is showing me here, it's all the vulnerabilities, right? All the different issues that I have on the libraries that I'm using, right? So I can have one library that has many vulnerabilities and many issues, or one library that doesn't have any issues. So we're going to see that here. And what's interesting is how that information is displayed for you, for the user, right? Even if you're a developer or a DevOps engineer, it's something that it's very easy to understand. Basically, the information here, just taking a look at this example, the first vulnerability here that we have information about the CVSS score, which is a score about the kind of the severity of that vulnerability. There is an information, the direct link for the vulnerability database from Snyk, which they have their own database, which is pretty cool. It has a lot of information out there of vulnerabilities. So you can take a look here as well, more information about the vulnerability itself, how to exploit it, how to fix it, and all that stuff. But the kind of the more important information is already available on the Snyk platform already. Two things here that I'd like to highlight in just this specific example is here it shows the version of the library that has this, that started having this vulnerability, right? 2.5.0. And then the version of the library that this issue, this prototype pollution vulnerability is fixed, right? So if I want to fix that problem, I need to update my library from 2.5.0 to 3.0.0, right? Another thing that's interesting as well is this kind of exploit maturity, right? So Snyk analyzes to see if there are any kind of public exploits out there being shared or developed or available on GitHub, for example. And depending on that exploit, if someone is using that to do kind of a mass attack of different organizations, that increases the kind of the risk score, right? That's how it calculates the risk score of the vulnerabilities. And you can see here that it's sorting the vulnerabilities by the highest priority, and the highest priority is this score that's using the proof of concept, right? If there is a proof of concept exploit or a mature exploit already available, it may not have any exploits yet. If it has a fix, right, there is an updated version for that library already, and you can just quickly update it and make sure that you're protected. And the CVSS score, right, which is high here, so it's kind of a big issue for us to fix that vulnerability today. Okay, so before, I know that we're almost kind of out of time here, but before we wrap up, I just want to show you how this project has a lot of indirect dependencies. Remember that I mentioned that on the kind of the synopsis research, they talked about 528 dependencies, right? Direct and indirect ones. So let's take a look. The kind of the direct dependencies here on this project that I see are these ones, right? And that's about like 31 dependencies, I guess, just roughly. Okay, these are the direct ones, but these dependencies can call other dependencies and so on. And if I take a look, Snyk already provides that information for me here. Here's the number of the dependencies that I have in this project, right? Which is just an example project that we use for demos and everything, but it already has 563 dependencies, right? Not all of them are vulnerable, right? And I can take a look here, and I like this format better, the kind of the hierarchy format, because I can easily see with the plus sign here which dependencies have other dependencies, and I can see, oh, this kind of indirect dependency also has a high vulnerability as well, right? So that's probably showing there on the results, the 83 results, right? But I can see how many dependencies I have in my code and why it's critical for me to update those. Okay, so last thing that I want to show before we end and wrap up for questions there, just how easy it is to fix this vulnerability, right? So we have two buttons here for each vulnerability that was found. One is to ignore this vulnerability if you think it doesn't matter or it's a false positive, which usually it's hard to happen. But let's see the fix this vulnerability, what this is going to do. Basically, this is going to open a pull request, right, at my repo on GitHub, because Snyk has permission to do that, to update that library to the version that's specified here, right, from 2.5.0 to 3.0.0, right? And it's interesting to do that because once you update that library and generate a new build of your application, basically you're safe from that specific vulnerability in that library, right? So let's try that real quick. It's usually pretty straightforward. When I select fix this vulnerability, of course, Snyk is going to show me the other vulnerabilities that I have, and if I want to update those, sometimes, especially when you're starting, it might not be a good idea to select everything because it can break your application, so you might not know what's causing the issue. So it's usually, I recommend starting little by little or library by library at least, so that if something goes wrong and your application stops working, then you can easily roll back, right, and fix it. Okay, so there are other options here. Let me go down. Yeah, open a fix PR. Okay, so let's see what that's going to do. Basically, we should see here now the GitHub page with a new pull request being generated by Snyk to fix that library. Let's see here. Okay. So here's the pull request. So it's done by the Snyk bot, which is the bot, the name of the user that Snyk uses to update those libraries. And it basically shows the changes or the files that are going to change and the library that's going to change, right? And what's interesting here is that this is a breaking change, right? It shows here that this might break your application because you're going from 2.5 to 3.0, right? So I'm not just updating a minor version of my library. I'm changing from 2.5 to 3.0. So there may be changes on that new version of the library that my application doesn't support and cannot work without any kind of changes from my side as well, right? And the files changed here. We can see the package lock, which shows the signature and the kind of URL where they download the libraries as well. Let me show here. Is that changing everything? Here, right? So I show the version that's changing and the previous signature of the library and the URL of the library. And here I can see the new one with the new signature and everything. But the other one, it's kind of easier to see. Let me go down a little bit. Yeah, the other one on package.json basically is changing just the number, right? So I want to make sure that when my application builds next time, I'm using the Dust.js LinkedIn library 3.0 and not the 2.5, right? And if I just accept this pull request, I'm going to merge it, this pull request here quickly. Once I merge this, Snyk is going to identify that there is some changes in my code, and it's going to run a new scan, and we're probably not going to see that vulnerability here anymore. So this Dust.js LinkedIn prototype pollution should disappear, right? So we had 83 issues before. If there are other Dust.js LinkedIn vulnerabilities that might be fixed as well. So let's go back and take a look before I know that I'm almost out of time. Just hang on with me here. Okay, so you can see tested a few seconds ago, right? So since there were no changes to Docker files, it didn't check again. I didn't need to test again because there were no changes there, but there was changes in the code and dependencies, right? So it ran the SAS scan and the software composition analysis testing again. So let's take a look. Okay, so now the first one that's showing is showing the Kerberos, which was in second place, but not the Dust.js LinkedIn vulnerability, right? So technically that was fixed. That's not showing there here anymore for us. And that was basically the demo. We were able to scan a project, right? Find the vulnerabilities, identify the dependencies there as well, and quickly change from a version of the library and fix this one library that we have in our code that we had a vulnerability on, and quickly fix that in about 5-10 minutes, right? That's how easy it is to do SCA, right? So yeah, let's see, go back here, stop sharing my screen. It's okay to get, okay. Yeah, that was it for the demo and for what I had today. I hope that you enjoyed the presentation, and I'm happy to answer any questions there maybe.
That was amazing. Thank you so much. We do have a number of questions. Just before we go into some of those, and we're totally good to go over because this is the geeking out community spirit that we know and love. But I just wanted to say so many points in that Prezzo that resonated so well. In particular, like governments now adopting supply chain security laws or putting into place those security laws. That one has been really, really interesting for me as a developer, as a technology, as a DevOps person. In particular, for IoT device firmware, starting to see so many governments now even adopting for that, which I think is really, really cool. So one question I did have is, how often do you think that the bill of materials, the SBOM, how often do you think that that should be generated and reviewed?
Every scan, every change in the code, right? If you change the libraries and the dependencies, you need to generate a new one, right? So you need to keep that up to date as much as possible, because like tomorrow there is a new vulnerability and you don't have that updated in your SBOM, then it's not going to match, right? So you need that dependency metadata information up to date and available so that you can easily match with the vulnerabilities that you may have.
Yeah, awesome. So we do have a number of questions across Discord and also from YouTube. So first one is from Vitor. Let me put that on the screen. Could you show later how to use Sneak on Jenkins if possible, or recommend a post or a blog?
Yeah, I don't have an example readily with Jenkins. I do have with GitHub Actions. So let me see here. There's some cops. Let me post the link here for you. But yeah, with Jenkins, I don't have an example here. Unfortunately, I can help, and I know Vitor can help you with that. But this is the I sent you on the private chat there. This is the link that I have for a GitHub Actions of DevSecOps tools. So basically, it's you're doing SAST, DAST, and SCA, and the SCA solution that I'm using there is Sneak. So you can quickly do that with GitHub Actions, right? It shouldn't be too hard to do that with Jenkins. I think that Sneak has a plugin for Jenkins as well, so you can easily integrate that. So yeah.
Yeah, we do. There's some tutorials too, but yeah, have a look around. But also, I posted the GitHub as well. Next question we have is this one. This one's a good one. Well, I mean, they're all good questions. But should we scan unit tests and dev dependencies from Rex?
Okay. I don't think so. Unit tests, they usually don't go to production, right? It's not affecting my application there. And I'm not sure what you meant about dev dependencies, but I don't know. Like if that library, if that dependency is going to production and that's in your application that's exposed somehow, then probably yes. But unit tests, no. Unit tests, you probably can ignore those. Yeah, they're probably not gonna have a lot of dependencies there. So anyway, so yeah, should be good.
Awesome. Keep those kind of questions. We have more questions coming in, so keep those questions coming in, everyone. So we'll go to Discord now. Leof, and I hope I said that right. It says, "Hello. Does Snyk use its own vulnerability database, or is it using a public database?" I have the answer to this one, but I'll let you answer it if you.
Yeah. I think I covered that here, but yeah, Snyk has its own database, which is really great. It has a lot of resources and a lot of vulnerability information there. So it's just it has more information, especially on libraries and packages and everything. So it's readily available, right? I think there's a link there, vundb.snyk.io, vun.snyk.io, something like that. That you can easily search, right? So if you don't want to even start using Snyk, you just want to check a specific library, right? You can go to that database and type the library name there and the version, and you can check. You can easily check for that information, which is kind of nice because it's free, right? Yeah.
Yep. I check that page that you mentioned. I check the vulnerability database list every day just to see what new ones are appearing on there. Because I mean, that's how I build some of my demos. But also, I just find it interesting to see. Actually, on that, one of the things I did notice last year, which I haven't seen too much on yet, but TensorFlow also started to get some reported vulnerabilities in it as well, which I am still very curious about. Anyway, I check it daily.
Nice.
We have loads more chatter coming in, so
Sure.
let me pick through. All right, Zach says, I've been geeking out over security for the last, wait, let me put on screen. It's a long message. I've been geeking out on security over the last month and have been evaluating a bunch of tools and getting familiar with concepts. Someone recently recommended checking out AAA attack vectors, and I'm going to put the next one up, and blast radius. What other concepts would you recommend studying up on?
Okay, let me check here. AAA, attack vectors, or blast radius. I'm not sure what AAA means. If you can, yeah, give me. You do?
I'll put it back up. I'll put it back up.
Okay. Yeah, if it depends. Like, I'm not sure if you're talking about specifically application security, right, or security in general. So that would be more generic answer there. But with application security, you definitely want to look at static analysis, dynamic analysis, and software composition analysis. Those are the three most kind of solutions out there. Oh, access authentication terms. Okay, nice.
There you go.
Yeah, that's important too. Okay, I haven't seen that term for those three letters there, three words there. But for I would start, like, if you're just starting out, I would take a look at the OWASP top 10, take a look at the risks there, the vulnerabilities, how to fix those as well. Understand about there are other kinds of application security tools as well, new ones if you want to check it out. There's IAST and RASP, right? Interactive application security testing and runtime application self-protection, or just the regular web application firewalls as well, which is a good kind of tool to have to protect against attacks. But yeah, I know it's a lot of stuff, but I'll probably start with the OWASP top 10. That's how I started. That's how I kind of shifted from developer to application security, was learning the OWASP top 10 and doing some understanding the vulnerabilities there, SQL injection, cross-site scripting. So that's kind of my recommendation there.
I think that might be all the questions, but I think people still want to talk. So actually, we did have a request to jump into the voice section, voice section, the voice channel on Discord. If you had time after this, there was somebody over there wanting to jump in. And people on the live stream, if you're not on Discord yet, please join us to Discord. Let me grab the link again. Oh, I can't copy from there. Let me grab the link. But yeah, please join us on Discord and we'll jump into audio chat and connect.
Okay. Yeah, we can chat more there.
I'll put the link into the chat. And for anyone on Discord already that's watching the live stream, we'll see you in the audio section. In the audio, why do I keep saying section? We'll see you in the audio channel. Anyway, but yeah, we might wrap up there. It was just totally tangenting, ad hoc, because I thought I'm going to close this up, but you could close it up too if you wanted to. But anyway, we'll see everyone over in Discord. And yeah, thank you all for joining us. But yeah, if you haven't yet, please join us on Discord because we're about to jump over there and connect and talk all things DevSecOps. So we will see you for the next one really soon. Keep an eye out on the meetup page, on our YouTube and on our Twitter, and we'll announce the next meetup soon. But thank you all for joining.
Thanks, everyone. Thank you.